we're going to use our calculator now to find the sine of 12 degrees, 40 minutes, 15 seconds. We're also going to use our calculator for some other calculations as well. So make sure you've got it handy, because that's what this segment's all about. Okay, in order to find that value, remember, this is going to equal, let me get it off of yellow. This trig function is going to equal a fraction. And a fraction is just a division problem. It should say division problem. That ends up equaling some decimal value. Okay, so it's important for you to know this part right here. A fraction ends up looking just like a decimal value after you do the operation of division. So our calculator is going to go from, when we put this in our calculator is going to go from here to there. It's not going to show us the process of the fraction, the division problem, and then giving us a decimal. It just gives us the decimal value. Sometimes we can lose sight of that. So we've got the sine of 12 degrees, 40 minutes, and 15 seconds. What I need to do is I need to first convert. So I need to convert this in my calculator. Now, some calculators will allow you to enter degrees, minutes, seconds, and I will show you that. But for those of you who don't have the fancy calculators, we're going to convert first. And converting doesn't necessarily mean getting the value. This is what I mean by converting. Instead of 12 degrees, 40 minutes, 15 seconds, we're going to enter into our calculator 12 degrees plus 40 over 60 plus 15 over 3600, and then end parentheses. And that is our degrees. So in my calculator, I'm going to have 12 plus, and then I can use my fraction bar, 40 over 60, and then I can use my fraction bar again, plus 15 over 3600. So my calculator is going to show me 3041 over 240. But your calculator might show you this decimal amount. Now, how do I use this entire value without having to round it? Because if I round it, I might get a different answer than everybody else. Well, we're going to use our sine function. So our sine function of this value is going to go into our calculator. Now, your calculator, see how mine says RAD? That means radians, and we're working in degrees. We haven't talked about radians yet, but we're going to. So for now, what you need to know is we need to make sure that our setup, however your calculator works, you're going to want to change your angle measure to degrees. So it's calculating in degrees, not radians. Now, you may have a calculator too that allows you to just bring this answer in. So I'm going to hit sine, and then I can just hit, in my calculator, shift answer. And it's going to bring that exact value in. If I don't have the ability to do that, I'm just going to put sine and then in parentheses 12 plus, and then if I don't have the fraction bar, I can just put 40 divided by 60 in parentheses plus, and then 15 divided by 3600 in parentheses. Just make sure that you've got all of your calculations in bigger parentheses. So I'm going to come back here and show you. Now I'm going to round to 4 decimal places. 2193 is going to stay 2193 because of this 4. So 0.2193 is our answer. So it's approximately, remember, that division problem, which ends up being a decimal value, is 0.2193. And remember, we talked about this being less than 1. Sine and cosine values will always be less than 1. So that's a good thing, 0.2193. Now, what I'm talking about with the parentheses is make sure that when you're putting your calculations in, all of that calculation is in bigger parentheses. And then if you have to use smaller parentheses, you would use those parentheses and then perhaps another set of parentheses right there. My parenthesis went through the 3600, but I can fix it. Here we go. There we go. So you can put those into parentheses, just make sure there's a plus sign in between. So you're going to need to get comfortable with your calculator and how it works. And through practice, you might even want to do the same problems several times. You don't have to have different problems to enter into your calculator. You can just do 3 or 4 problems, the same ones, just do them over again and get used to the buttons on your calculator. So with that said, let's practice. Let's do some more practice with our calculators. So let's find the sine of 49 degrees. Let's then find the cosine. Actually, I'm going to let this be a secret. Let's do the sine of 49 degrees first, and then we'll see where we're going to go from there. So the sine of 49 degrees. So you're going to hit sine and then 49. I'm in degree mode. You can see my calculator's in degree mode, and then I press enter, and I get 0.7547. So that is approximately 0.7547. Most excellent. Now what I'd like you to do is I'd like you to try to find the cosine of 41 degrees. The cosine of 41 degrees. Let's see what that is. So you might be a step ahead of me. I'm going to go to my calculator. I'm going to hit the cosine button. Cosine 41. Oopsie. Okay, cosine of 41. Enter. Look at that, it's the same value, approximately 0.7547. Were all the decimals, or was that just a coincidence? Let's look, let's see. No, all of the numbers are the same. Okay, well, let's try another. Let's look at the cosine of 32 degrees. The cosine of 32 degrees. What is that? So we'll go to our calculator. Cosine 32. We're in degree mode. Press enter. And we get 0.8480. 0.8480. Okay, that's good. That's a good number. And then let's find the sine of 58 degrees. Not sure if you can figure out what I'm doing here, and that's going to be an approximate, not an equals. Go to the calculator, and we're going to hit sine of 58. Press enter. Oh, this is the same value, 0.8480. Okay. Can you see what I'm doing? I'm not sure. Okay, so let's try one more. The sine of 12 degrees. Let's go over to the calculator and put that in. Sine of 12 degrees. So sine of 12 degrees. Enter. 2079.2079. Now, if I want the cosine of an angle to be approximately 0.2079, what will this angle need to be? Can you tell? Can you see? Can you see the relationship? Let's use a highlighter and see if we can figure that out. We've got the sine of 49 degrees, the cosine of 41 degrees. Okay, those angles are not the same. I wonder what the relationship is. Let's look at the next. 32 degrees, the cosine of 32, and the sine of 58. What's that relationship? Well, 49 and 41 are 8 degrees apart, but 32 and 58 are not 8 degrees apart. Oh, look at this. I think I got it. 49 plus 41, that's 90 degrees. 32 plus 58, that's 90 degrees. 12 plus, try 78. So let's go to the calculator. The cosine, drum roll, 78, enter, and it is exactly the same as the sine of 12 degrees. So the sine of an angle, let's call it theta, is equal to the cosine of 90 degrees minus theta. Because when we add the two together, they add to 90 degrees. And the cosine of theta is equal to the sine of 90 degrees minus theta. There's a very, very important way to address these two angles. These two angles, this angle and this angle, are complements. They are complementary angles. Complementary angles. Complementary angles add to 90 degrees. And we have two more problems here that I want to go into. They do involve using a calculator, but it's this last one right here. Actually, I can do this. We can do this without having to start another video. Let's finish it right here. We're still going to need our calculator for this problem right here. We're going to find the acute angle to the nearest 1/10 of a degree. So we're going to go out 1 decimal place. This time, when I put theta into my calculator, what do I put into my calculator so I can get 0.4721? So some of you might be thinking, well, let's just try entering values. So maybe we enter a 35 degrees. I mean, anything between 0 and 90. Oh, that's too big. So maybe I hit 20 degrees. Oh, that's even bigger. So we went the wrong way. So maybe we put the cosine of 65 degrees. We'll go the opposite way. Oh, we're getting closer. 0.4226. So I went just a little bit too high. So cosine of maybe 63 degrees. Getting closer. Cosine of 61 degrees. Getting a little bit closer. How about the cosine of 59 degrees? We went a little bit over. 63, it's between 63 and 61. You probably recognize that. So maybe 62. So we could do this, but look at what we've got to do. Oh my goodness. That's not quite it either. So now I'd have to start trying decimals, and that's not going to work. How can we just go straight to the answer? Well, this is an input here, right? You put in an angle, and you get out, we get out this decimal value. So what happens if we want to put the output in? When you exchange the outputs and the inputs, you have an inverse. So the inverse function is denoted with that -1. So now we're going to put the ratio in, and we're going to get the angle. We're going to get the angle out. So we're going to hit in the calculator the inverse function of cosine, and we're going to put that ratio of the two side lengths, which is a decimal, into the calculator, and let's see what we get. It should be 62-ish degrees. So in order to get the inverse, I have to hit the shift button on my calculator. Sometimes it's a second button, and cosine, and now you'll see that -1, and that tells you that the calculator is ready for you to enter the decimal value. So we're going to enter 0.4721. So now I'm putting the ratio in, the function value is going in, and the output 61.8 degrees. So very close to 62 degrees. 61.8 degrees, and that's an approximately. And that's a lot easier than having to, much easier than having to guess our way through it. So 61.8 degrees is the approximate angle that's going to give you 0.4721 as a trig value for that angle. Now, without a calculator, we want to find the exact acute angle. I'm going to come back in another video, and this one I'm going to do in its own video. It's not going to take long, but I really want you to be able to go to this video and replay it as many times as you need to without having to go through this whole video all over again.